Sir, we are live now. Please start.
Okay. Thank you, Balaji. Hello, everybody. Good evening. First of all, I wish all of you and your families are doing well and healthy and safe. I really urge all of you to stay inside, stay isolated, and remain safe. Let me quickly introduce myself. I'm Piyush Gupta. I am an engineering graduate and certified in management. And currently, I am employed with IBM System Development Lab, acting as an engineering program manager, program director. And I have been with the IT infrastructure industry for almost 2 decades, and mostly my focus area has been storage systems development. So in my current role, I'm the in charge of one of IBM's flagship storage product development group in India. Uh, I'm a social evangelist. You'll find me very actively participating technical social campaigns. So after this session, if you like to connect me over LinkedIn or Twitter, feel free to do that. We can learn from each other and share some good posts on technology front. As a part of this, while the session is going on, you still have an opportunity to post your questions using the link given in the description. There's a Google form given there. You can publish your questions there. Because in first 45 minutes, I'm going to cover my topic, and I'll try to use last 15 minutes to address some of the questions as much as I can. Uh, Today I'm going to cover about the changes in the technology and infrastructure specifically happening to address some of the today's changes in the workload. So we look at a little bit about it. I will provide you some guidance. I'll provide you my perspective. But as this is just a 40 minutes talk, so it's going to be very limited to a high level, or a 10,000 feet view, that what is actually happening in this whole area, and how the landscape is a little bit changing and where are we heading to. That's what we'll talk in next 45 minutes, as it's going to be a monologue, so I won't be able to get any feedback during the session. But please provide your questions in the Google form, and I will read them out and address them as much as I can. Okay. So with that, let me just quickly share the presentation I'm going to use to drive my discussion. Okay. Hope you see my screen. So the topic, the future of cloud computing and edge computing. The cloud computing and edge computing is not something very new. They are very known term for a very long time, but the way they are being used in today's architecture and solution is something we need to look at. Is something we should be keeping an eye on, that what is happening in this space. So first, what is the objective of this session? I briefly said that a minute back, but let me read it out again. The idea of this session and objective of this session is to provide a high-level view on the need of continuous evolution of computing architectures due to the constant change in application workloads. And our special focus is going to be edge and hybrid cloud computing, of course, because that's our topic. But that's a very important point you all need to know, that in IT, in the IT infrastructure space, things are changing very rapidly, because there are a lot of changes happening the way IT is being consumed. When I say the way IT is being consumed, means the workloads, the applications, the consumer base. There's a lot of change happening in that at that level. So unless we change the infrastructure, we won't be able to serve the requirements. So we need to really keep evolving the way we have been setting up our infrastructures and solutions to meet the requirement of applications. And when I say applications, ultimately the users, how the users want to consume this infrastructure and IT. So that's the objective. Let's see how much we can achieve it. But yes, just see this, if you can take away some of this in next 45 minutes. So let's step back and see a little bit of past, because that context is very much needed to kind of paint a story that why we are talking about hybrid multi-cloud today, why are we talking about edge computing so much. So to understand that, you need to little bit kind of go back and see what happened few years back. So cloud computing is not something which is very new. It's been in play for many years. It is a very successful model of computing. We have seen a lot of benefits out of that. But how did it, what actually made it happen? So if you look at when cloud computing was picking up and why people started moving to cloud, at that time the focus was to come out of some of the traditional data center limitations and challenges we had. So at that time, in summary, while I'll read these 4 bullets, but the summary was that because it was mainly driven because of the cost and operations. To come out of the cost and operations challenges, the cloud computing became a very important strategy for all the IT infrastructure decision makers. So at that time, when there was no cloud computing, when we were into silos, we were doing the traditional data center based computing. At that time, data centers were way underutilized. The utilization was a big challenge because the computing was done in silos. Every application had its own infrastructure, had its own running environment. So there was no guarantee whether you are leveraging or utilizing your infrastructure to the max capacity. And that's a big deal. If you're not utilizing your infrastructure, then you're losing out on a lot of compute power, which you otherwise can use it, or probably you're wasting that compute. So that was a big challenge, that how do we make sure that we are fully utilized? So that was a problem statement. Then traditional data centers also had a overall very high cost of ownership because it was a very high capital intensive. You need a huge real estate, you need a lot of energy, to run your machines. You need to procure a lot of capital, a lot of, assets using your capital. So it was a very high cost of ownership kind of affair, which was not easy for everybody to get in, right? Because not everybody had that much of dollar power to go and invest in this much of kind of infrastructure. There was another problem with the high entry and exit cost. In traditional infrastructure and the traditional data centers, it was very high cost to get in and also very high cost to get out. Because once you get in, you invest in capital, and when you want to get out, you lose a lot in terms of capital. So it was a very difficult entry and exit problem, which the traditional way of IT infrastructure was kind of posing to the decision makers. And then it was definitely a maintenance nightmare because in that era you needed very specialized skill to maintain these infrastructures, and there was a very lack of automation because one silo was not talking to the other silos, and every silo had its own skills to maintain those silos. So it was a big challenge in terms of maintenance. So these were the key, I would say there were many other reasons too, but these were I can say that were the key drivers to think what can we do to come out of these problems, and the solution was cloud computing at that time. So cloud computing, again, this is a picture coming out of Google. It's a standard picture. We generally summarize that what cloud computing offers to come out, to solve some of those problems. So it is actually nothing but leveraging some of the virtualization technologies and a utility-based deployment models to come out with a better computing model, to which actually allows you to start utilizing your resources and sharing your resources. Now the silos were broken. We broke those silos and kind of pulled all those resources together, applied a layer of virtualization, and evolved the whole new model of computing. It was a big boom. It was a big boost to the technology world. It was a big cost savior, and it was a very efficient, right? So it was a game changer of that time, wherein we just kind of found a way to reduce the cost of ownership, to reduce the overall cost of operations, to reduce the kind of entry and exit kind of a challenge which small organizations were facing because they didn't have too much of dollars to invest in. It was a game changer, no doubt about that, right? And even today, if you look at all the Amazons and Google Cloud and and Azure, and all these are solving big problems of past, which which otherwise was a pain. Now, this is the example. Now, again, I gave some examples of public cloud because all the Amazons, Azures, Google Cloud, and Ali Cloud, they are all public clouds because there's somebody else who is setting up a cloud for you, a kind of computing environment for you, which you use pay as you go, right? But cloud computing is not limited to just public cloud. It is also, the private cloud is another very, very important concept that the customers, the enterprises who are not shifting their workloads to somebody else in data centers or cloud data centers, they can still leverage the advantage of cloud computing technology by deploying the same computing model in-house. So that's another very successful model, because companies who had big environments, they could convert their traditional environments into a private cloud environment, which ultimately achieved the similar benefits of appropriate utilization, a lot of sharing of resources, scaling up, scaling down. So all these advantages could be achieved by even deploying the same concept on similar technologies in-house by big enterprises. So ultimately, cloud computing is a very successful model and which is still being worked upon, right? So there are enough data to suggest that almost every enterprise customer has a foot into cloud, right? Now, when I say cloud, we now in this session, we are not going to differentiate cloud between public and private. We are talking about cloud as cloud. Cloud is a concept wherein we are leveraging best of our environment, best of our infrastructure, and have the ability to scale up, scale down. We are more agile, more automated, right? So that's what we are referring to. So ultimately that solved the problem. Now, so the tagline says cloud computing offered great value over traditional data centers, and that's what we have been reaping from last many years. If you look at how things are changing today, what's wrong? There's nothing wrong with cloud. There's nothing wrong with public cloud, private cloud, but their requirements are going beyond which cloud computing or probably current model of public cloud or private cloud can resolve. So the problem statement of today are, we believe that people want to make decisions better and faster. That's a very, 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 broad statement. We want to make better decisions. When I say better decisions means we want to, leverage more power, we want to churn more data analytics to make better decisions. The data, I think we will see that in subsequent charts, that how the data is increasing. The data every day is increasing multifold. Data is of no value until it is converted into information, because data is just bits and bytes. This has absolute no value until you find a way to convert that data into information. And that's what we talk about, how you apply right amount of tooling, applications, analytics, statistics on top of the data to derive a better decision. Now, the other, the word in this line, in this sentence, is the faster decisions. It's just not about making right decision. Now we are in a very, very fast world. Things are moving very fast. So we don't have enough time to make right decisions. We need to be very, very quick. We need to be fast. So it's about right decisions and also fast decisions. So that's one of the important requirement. And we will see in the future slides that why our current infrastructure deployment models can't meet this requirement completely. Well, they are meeting the requirements. We are still doing all these things using our current deployments, but there are loopholes, there are gaps, there are scope of improvement. Now, second line says that we believe that you shouldn't move data to cloud that you will never use. Now think about it. Why should you keep pumping data to a cloud? Now, assuming that everything we generate go and get stored somewhere. And in this context, we are talking about we generate a lot of data and put that and save it in cloud. But do we really think that we should be keeping each and every data we are generating to the cloud? Answer is no, because data is being generated in exabytes and zettabytes, but not all that data is useful. We can all, and we need to really start thinking that how are we going to use this data and how are we going to filter this data so that we don't waste our resources to store that unusable data, right? Or use useless data, and apply any application or analytics, because everything has a cost associated with it. So we don't want to worry about the data which we think is not going to be useful. So why should we do that? So that's where it's not necessary that everything which gets generated in the form of data should be stored and pumped somewhere, which is cloud in this context. That's not required. Now, then what we do, I think that's what we will talk, that how the edge computing and this hype, is coming in play to solve some of these problems. Now, the third statement say we believe that your personal and private information should be protected. Very important point. And you would see that it's a talk of the town. Everybody's talking about data privacy, data safety, security. It's a big topic. It's a huge topic, and it's a topic which is at discussed at political level, at technology level, everywhere. So data, personal information, and personal data is very, very important to be safeguarded. Now, it's not necessary that that you place your personal data at all the places where it is not protected. So we need to protect that data. And how do we do that? And the last statement say that we believe that you should be able to continue operate your business even when the networks are down. Now, if you look at, we are highly dependent on the data, the data analytics, and making decisions on data. Think about an autonomous car. If autonomous car is making decisions to turn right or left or apply a brake based on certain decision making based on real time data, think about if there is a network outage and the car stop communicating with the engine, the data engine, I mean, who is making decisions for the car, what would happen? It will be a disaster. The car will go and crash somewhere and it will be a disaster. Because when I'm driving my car, there's a network between me and my steering and my clutch and brake. That's the only network we have. But now we are talking about connecting these devices, and making decisions over the network. So if there's an outage is possible. If there's a disaster and it keeps happening. Yesterday there was a cyclone. We were into cyclone when Gujarat was impacted, Maharashtra was impacted. If God forbid, if you are running autonomous cars in this country and you are making decisions through some central decision making or data processing unit, and you lose the network with those machines, what will happen? Either we just shut down those vehicles and just park them aside, that is still better, but still you are immobilizing them, or there is some kind of mishap happen. So ultimately, we are trying to say here, now the way we are using IT, it is very important to continue operation even when the network outages are there, because we are highly dependent on the infrastructure, and all the operations are highly dependent on some of these applications, right? So we can't afford to go offline. We can't afford to have downtimes. Think about an era of last 5 years. How many times you have seen downtimes on any of your banking application, or any reservation application, or whatever? Hardly any, because we cannot afford to have downtime, because it has a real financial impact, and sometimes it has an impact on lives, because even medical science is using so much of technology which is based on all this communicating between devices, because not sometimes the surgeries are happening through robotics, and if the robot is communicating with some other device, because that person if it is being happening on the network and there's a network outage, what will happen? So we need to start thinking about it. While it looks all great that we have such great applications of technology wherein we are leveraging more data, more analytics, more artificial intelligence, but these are some of the infrastructure challenges we need to deal with, so that we have a continuity of service, we have continuity of operation, and there's no problem of adoption of those use cases. So these are some of the high level key drivers, which I'll try to stitch it to the story of edge computing and how hybrid cloud is kind of becoming prevalent. So hope you understood the main crux of the slide, that these are few challenges which are becoming more and more relevant as we moving forward, because the way we are consuming things are very different the way we are consuming IT 5 years ago, or 10 years ago, or 15 years ago, and it is constantly evolving and changing. Okay, so what should we do? So when I say these are when I say these are the four problems, these are just four problems. There are many other problems. So what should we do? Place enterprise application closer to where the data is created and where action need to be taken. This is the one line statement which actually define edge computing. So what we are trying to say, the data is generated from somewhere, right? If I am driving the autonomous car, I have so many sensors in my car. It is actually generating data in the car. I'm generating a lot of data when I'm driving autonomous car. Now that's the place where we generate the data. Now what we are trying to say, don't take that data, because ultimately we are making a lot of decisions based on the data we are producing. there, right? So a lot of decision has to be made based on that data and applying a lot of other algorithms on top of that. So we are trying to say here that move, the enterprise application closer to them. Now you move your, algorithms closer to where the data is being generated. Now what will this, kind of give you in while we will look at it in all the slides, but ultimately it will allow you to kind of mitigate the problem of network outages, because you are not going too far with your data and doing the data mining and doing all the churning of the data and bring the decision back. You are traveling very less distance doing all that and bringing back the decision. So you are actually mitigating the risk of losing any connection by the time I get the decision back. So that is one thing. And the other thing is, it is also giving you the decision faster, because the farther you go, you take more time. The shorter distance you travel and get back your decision to the end, because ultimately decision, who is looking for the decision? The end device. If the car is generating data about who is driving in front, who is driving the right and the left, is there a pothole, is there a kind of guiding line or whatever, I'm generating, but ultimately the right left decision also is the car has to take. So ultimately the decision has to be passed on back to that device who actually generated the data to make that decision. So ultimately decision has to come back very timely. Otherwise, otherwise your use cases, you may not be able to serve those use cases if you take more time. Think about it. If my decision making takes probably few minutes or few seconds, or few more than 10 seconds or 20 seconds, I think I can't apply this technology to autonomous cars, because there I need to take decision on fraction of seconds, because a wrong decision in after fraction of second may cause an accident. So it has to be as real time as possible. And that's where the speed matters. So edge computing is nothing but what we are in a crux, in the summary, what we are trying to say, bring the algorithm, the application, the decision maker closer to where the data is being generated, so that you can make decision faster, and also you don't have a risk of you're losing that connection and you need to retransmit that data to make the decision happen, right? So this is probably the very short answer to some of the problems we are facing. And again, this is, we are not talking about all this in complete isolation. All this, whatever we are talking about, it is all supplementing to the great technology enhancement we have already done in past. Like for example, when I say cloud computing, today we are doing cloud computing, whether it's private or public or whatever. Now, whatever we are talking here is the next step. We are actually supplementing that innovation with some newer innovation. We are making it more, more strong and more robust and more capable to handle our current workload requirements, right? So it's not that we are getting away, or probably, we are ruling out one thing and bringing something new. No, we are implementing, we are bringing more feathers, and frills and feathers to what we already have in technology, and making it more robust and more applicable to the current use case. Now, this is a very simple, graphical representation that we have seen an era of mainframes, which, many years back. Then we looked at client server architecture, which was a leaner and, architecture. Then internet era, web application era came in, mobile computing came in. Public cloud is something which is very prevalent today. And we are now looking at building, edge computing on top of that. So I'm not saying that we are getting over from public cloud and bringing, it's basically a combination of cloud and edge, which is actually the demand of today. We need to work together, collaborate these two technologies, and actually evolve the solutions which are useful today. So if you read the line, decentralize the data, decentralized data and application processing across hundreds to millions of endpoints residing outside a traditional data center or public cloud is edge computing. You are basically decentralizing. We are not centralizing the computing. We are decentralizing the computing. While if you look at, when we talk about cloud computing, that kind of was kind of, we were bringing in multiple silos to a centralized computing space, right? But cloud was more about sharing and utilization, while we were bringing the infrastructure together. But I think the centralization, grid computing, you can think about, was more of centralizing the compute together and doing all the applications. But here we are talking about, let's just decentralize it and move back to the edges, move back where the data is being generated, and do that actual analytic, actual application of that data on those edges, rather than hold the data at one center place, do that algorithm, do that churn, and make decisions, and then pass that back. It's a very expensive operation. It's a very expensive operation, and it's not a scalable operation, because the biggest challenge of today is the scale, right? You just look at your own, just think about your own laptop or your own hard disk. A couple of years back, how much data were you had about for your own personal requirement? You just had few GBs. Now people are just not even able to satisfy their requirements with multiple TBs. So ultimately, we are scaling very fast. Now, how do we deal with the scale is something very, very important. So with the current centralized approach, definitely it's not scalable enough. The kind of explosion of of data and this all end devices on application we are kind of witnessing. So we need to think about decentralizing it and passing the responsibility to outside the data centers, and do certain operations in data centers, but allow certain operations through the endpoints or probably outside the data center, so that data centers doesn't become the overloaded and probably single point of failure, or probably a slow decision making entity. So that's what we are trying to achieve out of edge computing. Okay. So we just quickly look at the time. Okay, we are already 26 minutes. I'll quickly just move on because it's a big topic, so I can just keep talking on and on this. But I'll just try to give you this gist of the whole topic so that you can go back and do more reading and more discovery and investigation on this. So what just to understand what is actually edge, we have been saying edge. So what is edge? So in this picture, you very clearly understand what are we referring to as edge and what is non-edge. So we, on a high level, you look at there are two main entities. One is the edge, one is non-edge, right? And if you look at anything on the on the left hand side, these three pictures are we can consider them at edge, and all the cloud kind of infrastructure is your non-edge, which is basically an existing infrastructure sitting somewhere far away, and where we are pumping all the data today. So what we are saying as the edge is your all the end devices. Like in autonomous car example, which I'm saying again and again, is my edge device, because that's where I'm generating and creating the data, right? And so that's my edge device. Cameras, there are a lot of CCTV cameras. They are actually capturing the images. They are the edge devices. Machines, the robotic machines, they are the edge devices who are actually performing jobs on the on either automobile or any other shop floor. So these are the edge devices. Now, so edge devices are those who are actually doing the job and are probably generating the data. And then edge clusters is the next level, wherein it's a cluster of edge devices, you can say, and where you have, it's a next step, wherein you actually store and process your data. That's the nearest destination where you bring in that data and kind of process that. So take an example, in a bank, you have 100 CCTV cameras in a bank. Now those cameras are the end devices, but all these cameras are actually wired to a server room in the bank, where all these footages are being captured and being stored. So that becomes your kind of edge cluster, wherein hundreds of these cameras are being kind of plugged in into one entity or one server which is capturing that. So that becomes kind of edge cluster. And then now hundreds of these branches are being clustered to probably a regional branch. Now that becomes your metro edge. Metro edge probably one step above before you get into the cloud, right? So it's basically we are breaking this whole edge into three small components, just to kind of explain the concept. And it varies from application to application and use case to use case. But ultimately, we are saying that before we land our data into cloud, we have other avenues to kind of store our data and don't put everything on cloud, because that's the most expensive path to travel. If I need to probably think about it, if my all these CCTV cameras are directly feeding into my Google Cloud, or probably or my public cloud or private cloud, then I don't have anything in the middle. I'm directly feeding the data. I'm traveling, I'm capturing that image of multiple GBs or whatever. That data is actually thrown, probably traveling on the pipe, on the network, going to the cloud, and traveling this much of data is very expensive. It's not cheap. every kind of GB, or every bit of data traveling, you are paying to some service provider who is giving you this wire. So you're first of all spending a lot of money to travel that data to the cloud. Then you are actually spending a lot of resources in cloud to store that data and kind of process that data. And also you are adding more to the slowness of the whole process, because you are sending the data far away, processing and bringing it back again the same distance. So you are actually slowing down the whole, the workflow of the data, of this data for decision making. So that's what we are trying to get away with. And that's where these edge devices and intermediate edge gateways and clusters play a very important role in this whole concept of edge computing. So in this picture, if I again apply the concept which I said, what we are trying to say, that edge device become more intelligent, like camera. Today, it is capturing data, but can it be more intelligent to probably filter data to first level? Maybe yes. I would love to have a camera who actually don't throw me a picture which is not clear. The camera should be able to make a decision that, okay, if this picture is not clear at all, will not make any sense for anybody, let me not feed it back to my cluster or the cloud, because it's waste of money, because they are going to delete it later, because they won't be able to make any sense out of this picture. So can camera make that decision? Maybe yes. Maybe that's the next smart edge device who is actually not filtering at its own level. Maybe it's a small decision making that, okay, I'm making a decision not to discard this image while sending all the other images up. So that intelligence we can bring in, right? So that's kind of a very quick definition of what we are calling as edge and what we are calling as non-edge. Now, there's some statistics. If you look at today, 90% of workloads are deployed to public or private cloud. There's traditional IT, all the traditional IT data centers have evolved themselves into a cloud data centers, right? By using more and more advanced cloud technologies, which allow them to do more sharing of resources, more agility in terms of scaling up the capacity, scaling down the capacity. It allows them to kind of transfer applications and move applications seamlessly. It also allows them to do a lot of things automatically than with manual operations. So 90 more than in fact more than 90% enterprises have already deployed cloud computing in some or the other form. And just to tell you, now today most of the enterprises are looking at a hybrid approach. There's hardly any organization who is either fully public. I'm talking about enterprises, because the small agencies and small organizations who don't have their own data centers, they have no choice than just going public cloud, because they don't want to invest in their own infrastructure. So for them, public cloud is the best bet. But the big enterprise customers who have their own data centers, they're also looking at hybrid approach, that for certain applications they are leveraging their private cloud environment, certain applications they are using public cloud, because today we have evolved in terms of kind of integrating public cloud with private cloud. Today Amazon, AWS, Azure, or Google Cloud, all these cloud providers provide fantastic integration mechanism to integrate their public cloud with my private cloud, so that I can move things between these two clouds as in when I want. And that's what the concept of hybrid cloud is. That's a true hybrid cloud, wherein I'm not locked into one thing, and I can always, shift my workload between the cloud, and I can always make best use of whichever give me better value. Because certain applications are better you run them in-house, because that's more cost efficient. Certain application doesn't make any sense running in cloud. It's very cheap if you run them in public cloud. So that's where this hybrid cloud approach plays a big role. So 90% plus organizations are already doing it, are already doing some or the other form of cloud deployment. Now, by 2022, this is what Gartner is saying. By 2022, 50% of enterprise data will be created and processed at edge. When we don't have this implementation or probably this concept of edge solution, then everything which gets generation is still happening at edge. Everything gets generated at edge. But today, there are very few solutions wherein they are being processed at edge. They are being processed and in cloud, or whether it's public or private. But what we are saying here is that by 2022 or 2023, more than 50% of enterprise data would not only be generated at edge, but also will be processed at edge. So look at it. It's like you're saving a lot of, kind of investment of your cloud and doing that at the edge. But yes, it means we need to invest in edge processing. It's not that we are going to save a lot of money there, but ultimately it will make your user experience very different. It will make your the scalability requirement, where it will meet those requirements, because you can scale by adding more and more edge computing platform, more and more edge level processing platforms, right? So that's what we are witnessing, and this is what Gartner is predicting, that we are heading towards this kind of a kind of composition in 2022 and future. So I've not gone through because we are running out of time, and I'm just again checking the time. We are already 30 minutes over, and I have 10 minutes to wrap up what I want to tell you. So again, this is nothing but kind of explaining this picture. If you look at everything till metro edge, we are talking about putting all that into edge bucket, and anything outside that we are calling it as a data center, which is in most cases is cloud now. Don't talk about traditional data centers anymore. So it's public cloud or private cloud, and everything else outside public cloud or in-house data center is actually the edge processing, or probably edge, kind of edge device or edge platform, right? So that's what this is also referring to. Now, market trend driving edge computing. There are many reasons. I think we kind of covered that briefly. That digital business transformation promote decentralization of data, because every business transformation today is looking at doing things faster, doing things more efficiently, and also bring down the point of failures. Right. So that's the whole goal of business transformation today. How do we bring down the downtime? How do we make decisions faster? How do we reduce cost as well, right? So data, and most importantly, how do we secure? I think I didn't touch base on that. When you travel your data for a long distance, you are becoming more and more vulnerable. If you're not taking your data to a long distance, you are also kind of helping reduce your vulnerability. You are actually giving less, tap points for hackers to come in and sniff your data. So I think that's another very important point edge computing is kind of, handling, that you're not exposing your data, all your data. Definitely some data has to travel and go and store in the cloud, but you're not exposing all your data by doing localized, data creation and processing. Explosion of smart enterprise endpoints create massive amount of data. So scale, this is all about scale. The amount of data being generated is huge, right? It is hard to imagine that we would always be able to pump this much of data to a central location or a central infrastructure like cloud computing and bring that back to the edge, because ultimately data has to come back. So it is a very difficult problem to solve in the current way of computing. Enterprise generated data processing migrating to edge is the same statement. Now, the important one is the 5G accelerate edge use case, and 5G depends on edge computing. I think 5G is not something in India is still there, but 5G is not too far. So 5G networking is something which is already deployed in a lot of countries, and 5G is bringing a lot of promises to the applications in the space of AI analytics, because it's a very fast way of kind of communicating. It's a multi times faster than 4G today. We are using 4G today, but it's a multi-fold faster communication standard which is coming in. But 5G is a high frequency technology which actually cannot go long distance. So it actually rely on edge computing because it expect the data to travel a lesser distance to give the value of speed to the end user. So ultimately, edge computing is getting a lot of boost because of the 5G, standards which are being evolving, and very soon it will be a reality, right? In India as well. In some countries, it's already in production, but applications are being built with 5G, factoring in. And if we need to do that, we need to help 5G by giving data, at a, data to process at a lower distance than taking it very far. So I think that's where this 5G is also pushing a lot to kind of deploy edge computing as much as possible. Edge computing enables you to continuous operation. As I said, it's a continuous operation. Your reliance on a lot of networking hops reduces because you're not traveling multiple networking hops. If there is an outage at an upper layer of networking hop, your lower level of network is still intact. Your operations continue. So that's a big advantage. Then faster insight and action is the speed. This is the, I'm saying that by doing edge computing, you are actually enhancing the speed, you're reducing the latencies. So latencies is how fast you can get a response, how fast you can send a data and back, receive a response to that. That's latency. So we are reducing latencies by adopting edge computing. Better data control and cost. You're in better control, because nowadays there's a lot of compliance problem also we are dealing with, that this country say that my data should not go out of this my geography, and this data can go out, this data cannot go out, etc., etc. So we have a better control in, because we now have a flexibility, and we have that control that what we want to send across the border, what we want to send across the states, and what data we want to just keep local, right, for the security and privacy and on regulations purpose, right? So that is another big advantage which edge computing provides us. 27% companies are already using or aligning their business to get advantage from edge computing. So this is already being done, because it's not something, the concept is not old. We are just trying to leverage it for current use case. In next 3 years, it will go to 52%. So edge computing is an area. Again, I put this chart here because all you listeners see how much opportunity is there in this space. When I say opportunity, is an opportunity to invest, to innovate in this space, opportunity to work in this space. Because if some space is growing, it will create a lot of opportunities, because somebody has to develop, somebody has to deploy, somebody has to solution. So as a technical, kind of skill or brains, you all need to look out and watch this space, because this is going to open up a lot of opportunities in all aspects. Now, this is a very simple example so that you understand that. See, if you look at a picture, this is a shop floor of automobile manufacturer, wherein there's a welding robot who is doing the welding. And if you look at here, there's a camera deployed who's monitoring that what kind of welding is being done. Now there is a server here, edge server, which is in the on the factory floor, which actually look at what kind of weld it was, whether it was a good weld or a bad weld. Now, if we don't make use of this edge server, then this camera has to feed all this footage to the cloud computing or whichever central location you are processing it. And then that central processing unit has to take a decision whether this is a good weld or a bad weld. And by the time you're because it's a assembly line, right? The floor is moving, right? So it's a very fast, you need to make decisions very fast. So in this picture, the camera find a kind of a weld which is not good, which has to be rejected and need to be redone. So at this level itself, they're making that decision and passing that reject decision to the assembly line. And while the decision is made here, it's very close to the shop floor. We are not going to the cloud computing to make the decision. We are still going to the cloud computing to pass on the overall report, but decision is being made here so that action can be taken quicker and a job can be redone. So this is a very, very layman example of what we are trying to say when we say edge computing. Now you can apply this to n number of use cases, n number of industry examples. Now I think I'll just quickly skip a little bit, and let me just check if I have any questions coming up. I think there are a lot of questions coming up. I don't know if I'm able to read all of them and take care of them, but let me finish my slides and then I'll start reading some of them and address that. So ultimately, edge computing enable new business opportunities in every industry. In every industry, edge computing has an application. So it gives you a better connected experience. It gives you, it gives you a distributed IT modernization. It gives you a better supply chain and asset management. So I think now I leave it to you guys to go and read more about it. But I'll cover a couple of other interesting examples to give you the gist and the whole picture, the context of what we are talking here. Now, if you look at this is again many industry verticals wherein you can apply this concept of edge computing. Now think about the first one, the financial. There are many applications of this. I'll take one example of this again, CCTV. Today, what is happening is every bank has CCTV cameras in their branch. When you go to ATM, you have a CCTV camera there. You do your transaction. They are monitoring what you're doing. In most cases, what they are doing is they are just capturing and that just feeding that footage to a central server. And if I'm a fraud, I'm doing a fraud and playing with the machine, right? So camera is capturing it, but actually passing that back to the server, and probably a day later or whatever their turnaround time, they will, kind of investigate and start working on that fraud based on that footage after the fraud is done, right? And by the time they apply any protective measure, maybe some kind of damage is already done. Like I have kind of placed a camera or probably a sensor to read people's card number and CVVs. So by the time the bank take action on that fraud which was caught in the camera, probably some of the card details were already lost. I think they were already robbed. So if there is an edge computing, one application is deployed wherein now in that branch itself, you apply a kind of algorithm wherein if you find any fraudulent kind of action happening on the ATM like this, you immediately take action and disable some kind of transaction going forward. Just stop taking cards from there on. We will investigate the fraud later, but take some actions so that nobody is allowed to put or insert the card, right? So that device they do more damage. So it's basically making decisions on the fly and taking certain actions based on the decision. So that's a very good example wherein you cannot wait to look at this footage and make some decisions and then apply some kind of action. So that's too late in some cases. It's too late. So I think that's a very classic example which banks are already doing that. Then and there itself, if camera catch this kind of illegitimate activity, take this action and shut it down and just stop any further damage. That's one example. Now, the other very interesting example, which is there published in many online kind of portals, in vehicle, right? This autonomous cars are becoming very, it's a big buzz, right? Everybody is looking to buy a Tesla in India, and how can we use more autonomous features in that car. So there's a lot of enhancement and advancement happening there. So there's an application we can look at wherein if I'm driving a car and I'm feeling sleepy, and there are enough face recognition technologies available in the world today, wherein the car detects that I'm feeling sleepy, and immediately the car on the fly make a decision that my GPS has been advised that this driver is feeling sleepy, give him a route which is having a Starbucks on the way, right? Route him through a different path where there's a Starbucks on the way, and also place an order for this driver the favorite coffee, because now you know that this driver likes Starbucks and this driver like this coffee in Starbucks. So before the driver stopped by the Starbucks, the coffee is already ordered and already ready to be served, and the payment is already being made. So you're not slowing down his drive, but you added a complete new experience. So all that can only be done if you make decisions in real time. And how can we do that? We can do that if we bring the data processing as close to the data, where the data is being generated, as close to the edge devices. Because car mirror is actually guessing whether I'm sleepy or not sleepy. That's what that's the data being gathered. And if the decision can be made closer to that device, then probably we can make more real-time decisions and bring some great user experiences. Look at such a great, fantastic experience. I was feeling sleepy. My GPS took me to my Starbucks, and my coffee is already ordered, and money is already paid, and I'm fresh and ready for the ride. So these are very interesting, and these are very cases. These are just few I'm talking about. We are running out of time here, but if you go on the web, all these there you will find many even more interesting ideas. But all these ideas can only be applied and implemented if you have the backing of a strong infrastructure solution, because you cannot just think about an application and it will run on its own. It will run on certain platform, and until the platform support that application, because that application is nothing but a software. unless you can write a good logic, a good algorithm, but if the infrastructure doesn't allow you to run that algorithm fast enough, then you won't be able to provide that outcome very quick. So edge computing is kind of, kind of supplementing that capability of fast decision making by bringing the processing closer to the edges, right? Some of you already may know some examples of GPUs today, because GPUs are becoming so popular because of this lot of image processing. Every application has some or the other part of image processing, and GPUs has a big role to play in it because it has a dedicated, processor and kind of core to do that. So it's ultimately, that's another example of bringing processing close to the data, right? You're not going to the processor of the system, rather you're bringing processor close to the to where the data is being generated. So ultimately, in a form, it is some form of the concept of bringing processing close to where the data is being generated. So this is a very crude form of explaining edge computing. There's much more to that, to do that, because it's just not that it's very easy to deploy. It has big challenges. I didn't get time to get to those slides, but to do all this, there are huge challenges. That how are we going to deploy? How are we going to manage this? It's a huge management challenge. And when we are talking about taking the processing to the edge, we are again not creating the silos. We are not saying that you go back to the old model of every branch office having its own machine wherein they don't talk to anybody, and we are not going back to that era. We are not talking about going back to the silos. We are saying that taking the processing back to those edges, but still be the part of the same, same kind of workspace, I would call it, so that every edge in the world connected to one solution should know what is happening on the other edge, right? So it's all connected, but still allow you to do more decentralized processing and allow you some other benefits of decentralization, but still you are overall part of the same namespace and same workspace, so that we are still have the complete control of the environment and not a siloed one again, as we've seen in the past. Okay. So these are some some statistics of like how many devices, 21.5 billion connected devices by 2025. This is just a guesstimate. No wonder and no surprises that we have more than 21.5 billion devices, right? So devices are growing and your scale is growing, so that is going to create a bigger problem. Data generated. I come from the domain of data storage. We are dealing with so much of data, and as a part of storage system development organization, we are always challenged, we are always being given a challenge to do store more and more data in a smaller and smaller space. The form factors are reducing, the requirement to store data is going up. So we are given that challenge to take less space but store more, and just not store, about how fast you can read and write, how fast you can, because now you need to provide the data back to the application very quick. So it's a very kind of a challenging area, because the problems are just getting to the next level, and we need to keep working on those problem statements to provide solution. This we kind of covered. Yeah, so just new challenges. That's edge computing is throwing complete new set of challenges. Four main challenges: scale. Number one, scale. Definitely, so it's going to put you a huge scale problem. How you deal with the scale? Data, device variance. Now the edge devices are thousands and millions. No two devices are same. Everybody is using a different kind of edge device. So how do you deal with so much heterogeneity, right? How do you deal with so much of variety? So we need some way of bringing a common layer to deal with so much of device variance. Unmanaged data is unstructured, unmanaged. How you bring them together, label them, and how you play with that. And actionable data, how do you filter the data? Ultimately, as I said, not everything is useful. There's a lot of junk which is being created also. So if we, sometimes it's not 80/20, but it's a kind of a say that sometimes it's 80/20. It's always we need to spend 80% of time for 20% of priorities, right? So same with the data. There's always very small set of data which need more attention than 100%. So you need to have a way to find out what is that important data, because it's not very easy to find. So we need good way to filter and find that actionable data, that what is my most important data and what data I can probably just leave it aside. I think scale, this is a picture which tells you from cloud computing, we are talking about 2 centers. Now here we are talking about thousands because the endpoints are many. So your edge centers are many. So scale is going to be a big problem. I think this I'll just skip so that I can take some questions. I think I'll skip this, probably you'll read it. So ultimately, this is a picture which is little bit IBM centric. So IBM is heavily invested in this whole space, and IBM is already made a lot of progress. So you already know that IBM is Red Hat is an IBM company, and Red Hat has built great products, right, in the space of cloud computing, which actually solve the problem of a common layer between the cloud and edge. So that's what they call it, on OCP, OpenShift, container platform. So OpenShift is a cloud orchestration platform from Red Hat. So again, it's a very high level, kind of summary, but it is a great product which allow us to create a layer right on top of my overall solution, which include my edge clusters, my metro edges and public cloud, and create a common layer on top of it, because ultimately I should be able to see my complete environment at some level, because it's all belong to me. While something is at edge, something is not at edge, but I should be able to see all that together and should be able to action them together at certain layer. So it's great technology and very complex thing, wherein some of the cool techies are really doing fantastic, phenomenal job to solve this problem, right? And which we as an end user will see when we drive an autonomous car, or when we kind of go to a shop floor. I think that's the outcome, but behind the scene, this is what being done at an infrastructure level to support those use cases. Okay, so in summary, edge computing improves business outcome in real time with resilience and security by placing enterprise business logic and AI application closer to where data is created. So ultimately, we are bringing all the business logic and AI algorithms closer to where data is created, so that we can make decisions faster, we secure our data, we deal with the scale, we deal all these problems by bringing this new concept of edge computing. Okay, so I'll just stop here. I think we are left with just probably 5 minutes, and if we can go over 5 minutes, I'm happy to do that. Now I'll just stop here. I'll stop sharing and start reading some of the questions. So there's a question from Ronak. Which cloud facility is better? Cloud is safe or not? What can I use? What can I use any cloud for build a website? What is the cost of it? Which one is more trustable? AWS, GCP, Azure, none of the above. So, well, I think there are many questions in one question, but ultimately it boils down to your concern of security and cost. So see, cost is something which you need to explore, what you need, right? And every cloud provider will have its own way of, kind of estimating the cost of what resources you need. So I will leave it to you. You go and do your estimation, and these are free estimations. You can do your free estimations on all cloud providers, and whichever is cheap, you can go and go with that. Now, security. So from security standpoint, I'm telling you, the cloud providers have done a fantastic job by solving that problem, because security was always a big deterrent for cloud adoption. And today, while there is no end to security problem will always be there, because the hackers are smart developers. They are nothing but the developers who are more smarter than people who could anticipate the loopholes, because ultimately every developer and architect is actually looking at, we don't leave any loopholes, any vulnerabilities in the system before they release that system. But hackers are those developers who are able to crack it and still get in. So they are the smart guys. So you will always have some smart guy to break into. Now the question is how best we can deal with it, right? How best we can deal with it proactively and reactively both, right? So cloud providers today, they are, in my view, again, everybody, it's a matter of kind of investigation on case to case basis. But in my view, every public cloud vendor has done a great job in terms of enhancing the security of public cloud. So, and especially for your kind of use, you want to build a website, I don't think so you need to worry about the security aspect of public cloud. They are very secure, and you can probably go and even you can kind of query them that how are they going to secure. So you'll find enough content on the web to answer that question. But yes, in summary, I don't think so. We have a big security concern with public cloud anymore because they have evolved a lot. Then there's another question on security is a major concern about cloud computing. While security is a concern not only for cloud computing, it is also a concern with non-cloud computing is a concern for everyone. So yes, cloud computing is a methodology wherein somebody else is using, kind of processing your data. But I think there are enough checks and balances, and there's a constant enhancement and evolution of security, checks and balances, which I think is taken care of very well in the public cloud space. Then Revathi, there's a question: how is cloud computing related to financial sector? Is it something which should be known to finance students also? No, I think if you are finance student, I think you are the user of the application, you are the user of the technology. But definitely knowing how the technology is deployed behind it, it's always interesting and you can read about it. But if you're a functionally a financial student and you're studying finance, then you should be worried about your application, then how it's being used behind it, right? And you need to leave that to people who are responsible for deploying those applications. Then Jatin, there's a question from Jatin. How the share market will be affected by advancement in cloud and say other AI and ML technology? That's an interesting one. So definitely share market is nothing but the reflection of, if I keep the speculation aside, see speculation is a share market also runs on speculation and there's no answer to that, right? There are big stock market, kind of analysts who also can't explain you why someday market went up and came down. It is based on speculation. But if we talk about the rational, uh, so stock market is based work on certain rationals also, and rational is nothing but if company is making profit and company has better margins, company can show you, kind of a better profitability, then the company is good. The stock should go up because ultimately the company is profitable, making profit. So ultimately, any technology, if that can bring in the value in the margins and profitability of a company, is definitely going to impact its image in the market, and it should definitely reflect in the stock market as well. So yes, why not? The companies who are deploying good technology, right? It is actually nothing. It's not only about their current operation optimization, because they definitely prove a point in the market that we are the company who believe in optimizing our operation using technology. That's a great statement. It means they are saying that we are a futuristic company. Like if there's a sugar mill, if the sugar mill start applying AI and ML, it gives a very strong message, right? It gives a very strong message that, oh, they are the orthodox business houses, but they know that technology is the way to optimize the operations, and ultimately operation optimization will show up in my net profit, because I will have more same revenue, but if I reduce my cost, I will improve my margins, I will improve my profitability. So ultimately, yes, answer is yes. If the companies are investing in technology to be more optimal operationally, to be more profitable, then why not? It will show up in their performance, and their performance will actually show up as a stock price. Again, speculation can take a good profitable company also down. That I can't comment on. But if we go by rational, answer is yes. The role of cloud computing, the question from Dr. Tata, that the role of cloud computing present and future, very strong role. I think cloud computing is playing a very critical role by kind of bringing a lot of agility, lot of kind of automation, and and scaling up, scaling down, and it's a cloud computing has proved its worth. It's already proved its worth, so it is a proven kind of concept and technology. No, I'm not. Cloud computing is not a technology; it's a concept. So the cloud computing is a proven concept, and it is paying tremendous results in the IT world. So that's the reason more than 90% people are already on cloud computing in some or the other form. Now in future, idea is to build on top of it. We have learned a better way of using our infrastructure. We have learned a kind of better way of managing our infrastructure through cloud computing. Now we are going a level above to see how do we kind of solve our next set of problems by building more concept like cloud, like cloud computing earlier was, okay, one cloud. Then we came to hybrid cloud. How do we create hybrid cloud? Then, then came a time when now we are talking about hybrid multi-cloud. Like I'm a customer, I'm running one application from Azure, one application from Amazon, one application from private cloud, right? So I'm using multiple cloud, and I can always move my application from one cloud to the other cloud. Now Amazon and Azure are not mind, they don't mind it. They're in fact enabling those features that, okay, if you don't like me, I don't want to lock you with me. I'm not going to lock you. If you don't like my platform, tomorrow you go to Amazon, right? So they are enabling all that because that's how the future is. No one customer don't want any vendor locking anymore. So cloud computing, to answer your question, is very important concept today. Almost near 100% deployed and kind of practiced, and has a very bright future because ultimately this has to evolve. We need to keep evolving and make it even more robust and kind of more useful for our applications. Okay, so there are too many questions. I don't think so I would be able to. There are more than 100 questions, near 100 questions. Mm. The question is, sir, how can a non-engineering student get into cloud and edge computing? Yeah, so certainly engineering student, like to give you an example, I know a lot of civil engineers doing very good IT design, right? So they studied civil engineering, but they are fantastic designers today because they chose that career and they learned over time. So I don't think so. It's that if you are not a hardcore engineer, but you definitely need to gain certain academic knowledge, which you can definitely find out what you really want to do, and you can build on top of that. If you are interested in this space, you can always study and learn it. Why not? Mm, how edge intelligence is different from intelligent edge? See, probably see, intelligent edge, I kind of gave you example that can we make our cameras more intelligent? Uh, can we make cameras to, or edge devices, sensors more intelligent? Like today, all the sensors, what they do, they just sense and pass the report to somebody else. Can we put another, kind of chip into it to start doing one next level of decision, right? That sense this. If you sense this, then sense this as well. If you don't sense this, don't sense this as well. So something I'm saying that, can we make our edge more smarter? If we can make our edge more smarter, then we solve a problem of not passing on a lot of junk to the edge server because you are applying a filter. Ultimately, what do you do in your filter? In your filter, you are taking the junk out, right? So every layer, you are ultimately doing some filtering, means you are taking junk out at each layer. So you, as much as filters you apply, you can start taking junk out at each layer. So you make more even better use of your edge servers or cloud servers for the data you actually action, rather than spending time and cycles and money to start taking the junk out. So by having intelligent edge devices, you can probably have another filter in the edge device itself to throw some junk out and only send the relevant or useful, first level of filtered data to the upper layer. So that's probably, you can say that that's the main difference you can say in between intelligent edge and non-intelligent edge. Okay, so we are, I think, already at 7:08. I'm not sure if we can take it further longer. Balaji, if you can hear me, can we extend the session further, or should we be stopping here?
We can go. I mean, it's totally up to you, sir. Just, whichever question is relevant, please, you can
Okay.
take care.
Okay, so I'll probably spend a few more minutes because there are some interesting questions which might be
Sure,
useful
sure.
for people to know. How can we use, and this question is from Lalita Mishra, how can we use edge devices in integration with 5G for better healthcare solution? Okay, So see, healthcare is definitely is an area, which is evolving by using great technology, innovations, right? And if you talk about, I think I'm just because you mix two things here, the 5G and healthcare. So ultimately, healthcare is also a thing wherein you need to make decisions very fast, right? And now this COVID-19 situation has challenged a lot of IT folks to see what else can we do to kind of deal with such pandemic or such situations. Wherein, take an example, very live example, like today there was a time when we had 4 lakh new patients of COVID identified. Now that if you do the put the kind of profiling of this, now not all of them need, there are some asymptomatic ones, there are some severe ones, there are some very severe ones, right? So there's a profiling of each patient. So what is happening today, and that's a ground report, is a lot of mortality, a lot of deaths happening because of insufficient medical attention. And this is again, I'm talking about just related to filtering some junk out. Is there a way to filter out the junk? And or probably in this context, let's not call it junk, but I'm saying that filter out all those patients who don't need a MD, filter out all those patients who don't need even a MBBS. Maybe they just need a paramedical staff, right? So how do we do that? Is that all that is done manually today, right? Based on the assessments, based on their reports, there is somebody who is diagnosing and telling them that, boss, you need to get admitted, you need this. So there's a lot of manual thing happening, and ultimately there are some non-severe, kind of patients landing up to a MD doctor who actually is a better, doctor for somebody who is dying on some other hospital, right? So this is a very high level example that we definitely need some automatic way of, and by the way, in pandemic there was no time to turn around and find a better solution, because you need some time to design a solution and apply that. Whatever as a country we have done in such a short time to deal with this, it's amazing. While we have seen a lot of damage, but I think country of this scale, nobody could have done better than what we as a country have done. So but from here, whatever we learn, I'm sure there would be too many enhancement and a lot of innovation is going to come in medical space after this pandemic. And that, kind of would be solved. Some of those innovations would be built on top of some of these 5G technologies and edge technologies, right? How can we? So definitely, because you can do a lot of things based on sensors with a patient. Now, with those sensors, those are edge devices. Your patient is sitting there. Patient has all the sensors in the hospital attached to him. Now, can you make a lot of decisions? Can I collect that and start applying some artificial intelligence there to a certain degree and pass it on to a doctor only after reaching a certain threshold? So, yeah, definitely, there's a lot of scope to do innovation in medical space, especially after seeing this pandemic, and you will see that coming in. Hospitals will be automated, healthcare will see a lot of automation, a lot of artificial intelligence. Like I don't know how many of you know, and it's not a recent data. It was, I know there was a data published by whom, I think Manipal hospital or somebody. I think there was a study saying that the number of cancer patients in the world and the number of oncologists we have in the world, the ratio is very, very skewed. Like they have thousands of patients, like one doctor in many thousands of patients. It's impossible for us to deal with this kind of composition. It's impossible, right? So what we do, we need to definitely apply a lot of artificial intelligence to kind of do groundwork. Probably the 80% of the work can be done by artificial intelligence and algorithms before you actually go to and consume oncologist, right? So definitely yes, medical field is a area which has a lot of potential. We are not one of the best, kind of in this space in the world, and this pandemic has given big setback to all of us, that governments, scientists, everybody need to focus on medical system, that how do we make it more robust, because nobody can guarantee that after COVID there won't be any other pandemic for the whole, for the whole life. We need to be ready to deal with such pandemic, right? And there are white spaces which can be addressed using the technology like artificial intelligence, machine learning, analytics, and all that would be running on top of infrastructure, and that infrastructure is 5G. cloud computing, edge computing, offload GPUs, CPUs, DPUs. I think all these are your pieces of infrastructure which make your all this, great application work the way you want, right? Okay. What are the benefits? Now, this is a question from Aditya. What are the benefits of cloud computing on automation in the product development field? What are benefits of computing on automation and product development field? So automation, certainly. So cloud computing is it's certainly automation is a big advantage of cloud computing. And how are you able to achieve automation in cloud computing? Because you are actually breaking the silos and you're bringing the whole workspace interconnected, because cloud computing allow you to interact with different components of the business and apply any kind of, because if you think about automation, you cannot automate in silos. Because when I say automation, what does that mean? I say that I've written a script saying that if you find this condition, you do this, else you do this. If you hit this condition, then you go there. It's ultimately a kind of script which actually asks you to perform actions, based on certain results. And those actions need to be kind of integrated between different functions. Now, if different functions are not integrated together in the single computing environment, then how would you automate? Because then you are actually living in silos, and you cannot go out of silos, right, without manual intervention. So cloud computing broke those silos, bring all that departments, all those components together, and allow to kind of write a lot of automation and give you all those tools. Because I'm not talking about tools and technologies here, because I'm just talking about the concept. But cloud computing then enable you with a lot of tools and kind of technologies which help you to do that automation, right? So yes, automation, you in the product development, kind of in the industry, definitely cloud computing is very helpful in automating things. Mm. Okay, so I think we can probably job for freshers in cloud computing. Certainly, there are a lot of jobs. Cloud computing is in space. I think computing, if you look at, you will find a lot of jobs all around, because now nobody is doing an in-house application development today. If you develop any application, it has to be a cloud application. When I say cloud application, means you should be able to, if you develop this, you should be able to deploy that into a cloud environment. So cloud computing, definitely I think every application developer is kind of working the cloud computing space, because you're not developing almost any application today which is not cloud deployable. Okay, so probably we'll stop here, but it was a very different session for me, because it was a complete monologue. I couldn't hear anyone, and this is very unlike the sessions I've been doing in past. But I hope that it was useful for you all. And don't hesitate to connect with me on my Twitter handle and LinkedIn, connection. And we can always network, talk offline, and also I keep sharing a lot of technology trends and what is happening in this space. So watch that space and learn. I think I would say that learn as much as you can, because this is just the beginning, which I just said, and this is a very high level of concept. There's a lot devil lies in the details. You just need to go in detail and find out what make what interests you more, and learn as much as you can. So thank you very much. And again, I wish you all remain safe and and healthy. So stay at your home. Don't go out. Wait, keep some patience. Let this pandemic go away, and then things would be very normal very soon. I wish for that. Thank you very much. Over to you, Balaji.